Welcome to The Explainer. Let's just jump right in today because we are tackling something absolutely critical for any modern data team. We're tearing down the walls between local AI experiments and massive global deployments by designing and implementing a rock-solid MLOps infrastructure. Now, if you're prepping for the Microsoft AI-300 exam, you need to know this stuff inside and out because building this foundational environment makes up a whopping 15 to 20% of your total score. But honestly, even if you're not taking the exam, whether you're an AI engineer or a cloud architect, understanding how to actually run massive AI workflows in the real world is an absolute must-have skill. So here's the million-dollar question that pretty much every data science team is wrestling with right now. How exactly do you take a model from a local laptop and scale it up to a global enterprise? We constantly hit this AI bottleneck. It's incredibly easy to build a promising model in a little experimental sandbox. You're tweaking parameters in a local Jupyter notebook, the accuracy looks amazing, and you feel like a genius. But taking that exact same model and deploying it reliably, securely, and at a massive scale so thousands of users can hit it without crashing the whole system, well, that's a totally different beast, and it requires a completely different skill set. To actually crack this bottleneck, the industry uses a very specific structured approach. Basically, we have to separate the inner loop from the outer loop of model development. Think of the inner loop as your data science playground. That's your data exploration, your pre-processing, your training. It's super iterative, sometimes a little messy, and entirely focused on the data science. The outer loop, though, that is the domain of MLOps. That's all about production, packaging the model up, deploying it safely, running rigorous testing, and constant monitoring. A robust infrastructure is what physically bridges that gap, letting you move seamlessly from a cool experiment to an enterprise-grade operation.
So here is our roadmap for today. First, managing Azure resources. Second, governing AI assets. Third, automating with IAC. And finally, acing the AI-300 exam. Let's kick things off with part 1, managing Azure resources, which really acts as the foundation for everything else we're going to build. To make all these cloud concepts a bit more concrete, let's look at a scenario straight out of our study sources, Fabricom Inc. Imagine a mid-sized healthcare analytics company. Right now, they're migrating to a cloud-based development environment because, frankly, they're hitting some major growing pains. Their data science team is running training jobs manually from local notebooks, their experiment tracking is all over the place, and they're fighting over server resources during peak hours. They desperately need to modernize to fix these scalability issues, and they have to do it while locking down strict security for their sensitive healthcare data.
So what's the very first move for a company like Fabricam? If you're taking the exam, burn this into your memory. To centrally manage all your data, models, and environments, creating a shared Azure Machine Learning workspace is your absolute first step. It is the top-level resource. Think of it like the master container for your entire project. It's where your data, your compute, and your experiments all live and breathe together. Before you can even think about advanced features, you've got to have this centralized hub properly configured. Okay, once you have your workspace, you need an engine to actually run your workloads. On the AI-300 exam, you'll definitely be tested on choosing the right compute target for the right job. For training workloads, managed compute clusters, specifically AML compute, are your best friend. Why? Because they automatically scale for you. You literally only pay for what you use, which gives you that sweet cost predictability that leadership always wants. But for real-time inference in production, where you need blisteringly fast scaling and super low latency, that's when you bring in Azure Kubernetes Service, or AKS. Moving right along to part 2 of our blueprint, governing AI assets. Let's take a look at how we manage our inventory. Understanding how data assets are structured using formats like ML table is completely game-changing for machine learning workflows. When you register your training datasets as versioned assets, you are creating a foolproof audit trail. Think about it. If a model starts acting up, or if an auditor comes knocking and asks exactly what data trained a specific model from 6 months ago, you have a precise, immutable record ready to go. It's absolutely crucial for responsible AI governance. Now, to keep this governed workflow running smoothly, there are 4 key assets you absolutely have to register in your workspace: models, components, environments, and data assets. By registering them, they become versioned artifacts that you can reuse and track across any project. This is exactly how you stop your team from saving files on a shared drive with chaotic names like model_final_version3_use this one, and move them into a professional, centralized system. Let's zoom in on environments for a second, because this is a really common exam topic. Azure ML environments are essentially versioned containers for all your software dependencies. They wrap up your Conda or Docker specifications neatly with a bow. By registering an environment, you guarantee a consistent runtime across all your pipelines without ever tweaking your core training code. If a model trains perfectly in development using version 1.2 of an environment, you know for a fact it's going to have the exact same dependencies in production. No more, well, it works on my machine excuses. But here's a tricky scenario. What happens when Fabricam needs to promote a model out of their dev workspace and into their production workspace? That is exactly where Azure Machine Learning registries come into play. Registries are brilliant because they decouple your assets from specific workspaces. So if you need to promote a validated model across the whole enterprise from dev to prod without manually duplicating files and risking data drift, you have to use a registry. It's basically your company's universal catalog. All right, part 3, automating with IAC. Let's stop clicking around manually and build a real automated assembly line. When we talk about infrastructure as code, or IAC, we're talking about using declarative tools like Bicep templates to deploy our resources. This means your environments spin up identically every single time, which completely eliminates human error. Instead of someone manually clicking through a web portal, you just pass in parameters like your location and project name, and these templates handle the rest. They become highly reusable building blocks for every stage of your pipeline. And once your infrastructure is defined as code, you can use GitHub Actions to orchestrate the entire workflow automatically. It's a simple 3-step dance. Step 1, a data scientist pushes their updated code to a GitHub repo. Step 2, GitHub securely authenticates to Azure using stored secrets. Step 3, an Azure ML job is triggered automatically in the cloud. Honestly, this continuous integration and deployment pipeline is the holy grail of MLOps. Of course, to make this automation happen, your security has to be incredibly tight. You cannot just leave your cloud credentials hard-coded in a script somewhere. You have to create an Azure Service Principal, usually giving it a contributor role, and then lock those credentials away as GitHub secrets. Add in strict Git-based source control and tight network access restrictions on your workspaces, and you've got a pipeline that is both highly automated and totally compliant with strict enterprise security rules. Finally, let's bring it all home with part 4, acing the AI-300 exam. So the big takeaway here is that designing and implementing this specific MLOps infrastructure is worth a massive 15 to 20% of your total AI-300 exam score. We're not talking about a minor footnote here. Mastering workspaces, compute targets, asset registration, and automating with Bicep and GitHub Actions is a fundamental core pillar you simply have to grasp to earn that certification. But look, even outside of passing the exam, mastering these domains gives you tremendous, tangible value in the real world. A proper MLOps infrastructure achieves cost predictability through those managed compute options. It ensures centralized governance through registries and versioning. And it guarantees operational stability by automating deployments with code. It literally solves the exact operational nightmares companies like Fabricam face when trying to scale. So, I want to leave you with this core mission statement of MLOps. Deploying safe, scalable, secure, and reliable AI in production. The days of keeping AI isolated in a little experimental sandbox are completely over. So, what does this all mean for you? Are you ready to take your models out of the sandbox and build the resilient enterprise AI assembly line of the future? Thanks for joining me on this explainer. I hope it gave you some great insights, and best of luck designing your own MLOps infrastructure.